Welcome to AlphaNumericTricks. Today we are going to see the problems under equations reducible to standard forms. We have already three problems under this type. Next we will see the next problem. Find the complete solution of x plus pz the whole squared plus y plus qz the whole squared is equal to 1. In the last three problems, we solved the problems. That is, you have to find out the complete integral, singular integral as well as general integral. Whereas here you have to ask to find a complete solution alone. Okay, so just find out the complete solution. Now we will see how to get the answer for this problem. Find the complete solution of x plus p z the whole square plus y plus q z the whole square is equal to 1. This is our problem. Number this equation as 1, and here this is not any of the standard types, isn't it? Any of the four standard types, because all the terms, all the variables here present, and it is not any of these standard four types. So definitely this is equations reducible to standard forms. In the last videos I gave how to identify the problem. Okay, that is type of the problem. Now we write the problem: x plus p z the whole square plus y plus q z the whole square is equal to 1. This is our problem. Here as usual we have to substitute the values for p and q. Okay, p is equal to dou z by dou x. So you have x plus z into this p is dou z by dou x whole squared plus y plus z into q is dou z by dou y the whole squared is equal to 1. Number that is equation 2. After that we have to go for substitution method. So here we have dou z is there. So we have to take a capital dou z is equal to z dou z. Okay, that we have to take it. Other terms we keep as it is. Okay, x is equal to x itself and y small y is equal to small y itself we have to take. That is enough. Okay, and now we have to integrate this one. When you're integrating this, you have a z is equal to integration of z dz is z squared by 2. The partial integration also the same answer. After that you have to substitute the terms in the given equation 2. Okay, so x plus this z dou z is replaced by dou capital z you have to substitute, and this dou small x you have plus y plus z dou z, that is z dou z is replaced by dou capital Z by this dou y the whole square is equal to 1. And in your final, after simplifying this, in your final answer you just replace z by this z squared, but that z squared by 2, that is enough. Okay, and capital that is the small x and small y you have to retain as it is. After that you have to go for substitution, that is p is equal to dou z by dou x and capital Q is equal to dou z by dou y. Because here p z is transformed, so we take p is equal to dou capital Z by dou small x, q is equal to dou capital Z by dou small y. Depending upon the problem we have to choose our values. Okay, I already told you that. Okay, and so after this test term you have x plus this dou z by dou x is taken as p and this is taken as q. So x plus p the whole square plus y plus q the whole square is equal to 1. This is our problem. X plus p the whole square is equal to y plus q the whole square is equal to 1. And after that you have to take this term here. We have to separate the variables. Here p, q, x, y alone is present. So this comes under fourth type of problem, separable equations. So we have to separate x terms together and y terms together. So keep x plus p the whole square is equal to one side, and is equal to remaining terms y plus q the whole square you have to take it to other side. 1 minus y plus q the whole square. After that what we had to do, we had to find out the complete integral. This is equation is reducible to standard, any one of the standard form. This is type 4. Okay, so we had to write this is a separable equation. Okay, this number, this has 3, equation 3 is a separable equations. F of x comma p is equal to phi of y comma Q, because we are using capital P and Q, no? That's why we have to use this capital P and Q. And X and Y are, we don't touch it, so use a small x and a small y as it is. If you want, you take x, dou x is equal to dou capital X, that is, you can take as dou small x is equal to dou capital X, and dou small y is equal to dou capital Y. That way also you can do it. And after your simplification, you replace all the terms. X is equal to small x, y capital Y is equal to small y, and z is equal to z squared by 2, isn't it? Z squared by 2, that is the substitution you have to do here. Okay, this way also you can do it. And last, that is previous method, you have to take a dou small x is equal to dou capital X. That way also you can do it. Now, after that, you have to, how will you find a separable equation? You have to equate this to some constant, because these terms are squared. So, you take that constant is also square. So, x plus p the whole square is equal to 1 minus y plus q the whole square is equal to some constant a square. You can take it and equate each to this constant a square, each term to this constant a square. So, x plus p the whole square is equal to a square, and 1 minus y plus q the whole square is equal to this a squared. Okay, and here you can remove the squares, and you can find out the values of p and q, isn't it? So, you have x plus p, removing the square, taking square root on both sides, you have x plus p is equal to a, and here you have y plus q the whole square is equal to 1 minus a squared, or you have to find out the value of this, taking square root you have to do it. So, from this you can take p is equal to a minus x, and this term you have to take a square root, y plus q is equal to root of 1 minus a squared. Okay, after that you have p is equal to a minus x, you have to write as it is, and from that you have a q is equal to, you have to take y to other side, root of 1 minus a squared minus y you have. Okay. And then you have to, after finding p and q values, you have to use this dz is equal to pdx plus q. Use that only, use this formula only. We have to find out the values of p and q. Okay, substitute the values of p and q here. So dz is equal to, p value is a minus x dx, plus q value is root of 1 minus a square minus y into dy. Now you have to integrate this term. So integral dz is equal to integral of a minus x dx plus integral of root of 1 minus a square minus y into dy. You have to integrate this. What about integral dz? Integral dz is equal to capital Z is equal to a into dx. You can write it. So a into dx is ax minus x dx, integration is x squared by 2. This plus you have, and this is constant. So root of 1 minus a squared into dy. So integration of dy is y. So you have y into root of 1 minus a squared, and minus y dy is there. So minus integration of y dy is y squared by 2 plus this constant of integration c. Okay, so here we take x is equal to x, y is equal to y itself, and this capital Z alone you have to change it, Z squared by 2. So substitute that, Z squared by 2 is equal to ax minus x squared by 2 plus y into root of 1 minus a squared minus y squared by 2 plus a constant. This is our required complete integral, and our problem is asked to find out this alone. Okay, and if it is asked to find out solve, then after this you have to go for a singular integral and the general integral. Okay, that's all for this video. If you have any doubts, please provide in the comment section. Thanks for your time and thanks for watching. Thank you.